teach a lesson plan. So you guys are my guinea pigs. So if I mess up, you correct me or criticize me or tell me what I'm doing wrong. Anyway, I don't know why I'm picking the hardest topic to talk on, but it's hard, but it's simple. We're going to talk about the 4 fundamentals of forces of flight. The 4 forces of flight. So I'm going to try to draw a little. So there's 4 forces of flight, as we learn about it. That is an airplane. I didn't label it up. I'm trying to be kind of like airplane. So the first force of flight I want to talk about is lift. So when I say the word lift, what do you think about when I say lift? What would be lift? What is lift?
They're shy, but it won't last long.
It won't last? Do I just stay up here all day and kind of wait for that?
No, sir, you usually just pick on Michael or Griffin. And after a while, somebody else will start talking if you just really give those 2 a hard time.
Well, that is a hard question. I'll save some other questions. Lift. How do we get lift? I'm going to draw a, let's try this. All right. Try to draw a wing. And I think on your handout, you have kind of a wing there. It's got an airfoil. I didn't draw it too correct. So this is an airfoil. You notice on airplanes, the upper wing is a little bit wider than the trailing edge. So I put in a leading edge and a trailing edge. That should be tapering off. And then as that wing travels through the air, you have what's called a relative wind. I'm just going to put RW. This relative wind is like blowing on this airfoil. So when we have Bernoulli's effect, and I think on your handout you had some Bernoulli effect on there. You have Bernoulli's theory of flight, and I'm sure this is the first time y'all seen this, not the second time you see it. Bernoulli's theory of flight on your handout is about low pressure and high pressure. So I'm going to put LP up here, and high pressure. So as that wind blows over that airfoil, blows over that wing, it creates a low pressure. Where's the low pressure at? Top or bottom? Top. High pressure is on the bottom. So pressure, which way does it go? Does it go from high to low or low to high? Pressure's moving. That's a tough question. It goes from high to low. So if we want to take a high pressure, it's going toward the low. So the Bernoulli's effect says as the air comes over the top of the wing, the air comes over the top of the wing, creates a low pressure, and it gives that wing a sense of low pressure on top, so it's going to push that wing up. And that's what, I just lost my name. So that's Bernoulli's effect. You got a great illustration here on the top part of this. But, will an airplane fly just on Bernoulli's effect? What if we turn that wing upwards? Now we turn the wing upwards, so as in an airplane, what would happen if you're coming along, your speed's good, and you turn it up? What's going to happen to this airplane? It'll fall, continue straight, fall think would happen as you turn the nose up?
Yes.
What's gonna happen?
What do you think? Come on, Galen.
I'll be here all day, it doesn't matter to me. You're flying along, turn the nose up, what happens? Is it gonna go up, gonna go straight, or is it gonna fall? Emma, hey, ding, 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 Emma figured it out. Golly, guys, come on, let Emma beat you on this. Yeah, you turn the wing up, you'd expect it to go climb higher. And what causes that? We talked about Bernoulli's effect, low pressure and high pressure. But now we have a different effect. You turn the wing up. Relative wind is coming into it, just like a glider or anything else. What happens to a glider when you turn it up? It goes up. So we have another effect, which is on your handout. What's the second part of this? Bernoulli's effect. But you have Newton's law here. Is he on here?
Should be at the bottom, is that correct?
Yeah, next page, bottom page. Yeah, this is a great illustration of the car. Yeah, Bernoulli's principle is low pressure, high pressure. Newton's law, Newton's third law, each action has an equal and opposite reaction. Newton's law. So if we're flying along, relative wind coming in this way, you turn the wing up, that relative wind's going to hit the bottom of this wing. So the wind's going to hit the bottom of this wing, and it's going to have a reaction to push that wing up. So this is Newton's law. Really Newton's third law. Each action equal opposite reaction. So, we want to talk about lift. What do we have? We have two principles and theories we can go by. One is Bernoulli's effect, which is high pressure, low pressure. Well, this dotted line is called the mean chord. Somebody wrote this up, help me remember what a mean chord is. Put them over here. What is that? It's the mean chord. This is the mean chord, and that's the mean chord, so you remember that. So we have mean chord, leading edge, trailing edge, low pressure, high pressure, and lift. So what causes lift? Two things. Name them. Bernoulli effect. What's the other one? Newton's law. Okay. So now I ask the question, what is lift? Bernoulli effect, Newton's law. All right. We also, in flying, we have something called drag. This is the resistance of the wind or resistance to make it go faster. You know, you get a certain speed, but why can't it go any faster? So we have a drag. There's two elements of drag. Nice mark it up here. You got a lot of pretty marks.
It's gonna double two for me.
I don't know why I picked red to start out a bit.
I'll put those in. Piece of meat in this. So, I'm gonna put it in.
So this ladder is referred to a hair dryer and a ping pong ball. Also, we have an issue called drag, and it's the resistance of the wind. I think we have a sheet that we covered that. There's two types of drag. One is parasite drag, and the other one's induced drag. Drag is just kind of the resistance of the wind. It's what makes an airplane fly and say something different shape like a ball not fly. The resistance of the wind, trouble with the wind. Parasite drag is the design. You know, when you design different aircrafts, whether it's an airplane or a rocket, you design it to be aerodynamic. Why do you make it aerodynamic? Do what?
Reduce drag.
Reduce drag, yeah, exactly, that's the correct answer, exactly. Yeah, you want it to be aerodynamic to reduce drag, to have less resistance to the wind, so when an airplane's sitting still, it's got so much drag on it, just sitting still by the way it's designed. And it's got a low drag because it's sitting still, and that's called parasite drag. But what happens as that airplane or aircraft moves faster and faster? That parasite drag gets higher and higher because we've got relative wind against it. There's another drag called induced drag. And induced drag is just the opposite. It gets induced drag is when the wind comes over the airfoil and gives lift and all, and gives it a lift characteristic. So induced drag really gets lower and lower. As the airplane goes faster, induced drag goes lower. Because if you think about it, as the airplane goes faster, it doesn't really matter the shape of the wing, it's just got a lot of speed and it'll fly anywhere. Just like a rocket doesn't really have wings, but it'll go fast. So the induced drag is lower. So we have a parasite drag and induced drag, and this would sort of at a low speed, this is speed. So at a low speed, our parasite drag is real low. We're sitting on the ground, there's no drag, but as we go faster, we get more resistance, so that's parasite drag. But then as we increase our speed, our induced drag is lower. We're sitting on the ground, induced drag is low. But the optimum issue is, right in here, you want to find your optimum drag, your lowest total drag. And airplanes are designed to fly at, say Cessnas do 100 miles an hour. They're designed at 100 miles an hour to have optimum drag, which is the least total drag. And that's the way engineers designed this aircraft. This wing is designed to 100 miles an hour. It's optimum drag. So we've talked about two things. We talked about lift, and we talked about drag. And that's two of the four, I think put my time up here, four forces. So we've got lift, we've got drag. Now we're going to talk about something we all know about. We have weight. What is weight? Big again?
Force of gravity acting.
Yeah, forces acting on it. So, does it matter how much you, so if you get in my airplane and I ask you, I said, how much do you weigh? Why am I asking that?
So you can calculate how fast you have to go, so you're not almost everything.
Absolutely. I mean, if I loaded up my plane with, 50 pounds, 100 pounds, we're okay. But if I loaded up with like 600 or 700 pounds, what's going to happen to my airplane? It's not going to do very well. So weight is really important. And the opposite of weight is lift. So depending on how much lift I have, depends on how much weight I have. So we talked about weight. There's two types of weights. One is just the force of gravity. So we all understand gravity, all understand weight, so one of it is just the force of gravity. What would be another way to make my plane heavier? This is a trick question. So we're flying along. Where's my plane? We're flying along my plane, and it's got two people in there, and we're flying along doing just fine, and the wings are holding the weight up. How would I make this airplane heavier as I'm flying along? I want you to think about this. What if I made a turn? What if I turn the aircraft? Does the airplane get heavier when I turn? So what you think about this? So I'm coming along, and all of a sudden I turn. Does this airplane get heavier?
Yes.
Well, the answer is for yes, whether you guessed it or no, it's yes. Ever heard of centrifugal force? A centrifugal force, as you bank the plane, it's gonna get heavier. It's gonna wanna go like this, isn't it? It's gonna wanna sling out. Say, so you have a centrifugal force. Anybody ever heard of a G factor or G load or G, 1G, 2Gs? That jet was flying at 3Gs, 4Gs. That's the factor of gravity. So we're all here, we're all 1G because we're all one gravity. But as you fly, you have different G forces here. So you have a think about it this way, we have 2Gs, as this airplane is flying along and it banks, it has a G factor, a centrifugal force. It's kind of like riding your bicycle. You feel, when you're riding your bicycle, you make a turn at a high speed, you just turn the steering wheel and make a turn on your bike. You don't even ride bikes anymore?
No.
No? You know, on your bike, when you're turning, you just kind of lean into it, don't you? It's kind of lean because that centrifugal force will carry you, and you can kind of feel the weight going down. When a plane turns, it creates more G's, so it's got 1G, one gravity. As it turns, it's 1.2, 1.3, and you get 2 G's. So at 2 G's, you're at a 60-degree bank, you're at 2 gravities. And so this plane is now weighing twice what it is. So if you weigh, if you weigh 100 pounds, when you turn, now you're weighing 200 pounds. That's the force. So that's our other way of having weight is, I'm trying to get this right, is load. So we have weight either by the weight of what we weigh, which is gravity, or we have a centrifugal force, which is load. So 2 ways to have weights. So we've covered 3 of them. Covered lift. Did a terrible job on your board here. I'm terrible.
I like your diagram.
I don't.
I
I'm
do.
sloppy.
I like that.
What's the other factor? Any idea?
Thank you.
What was that?
Thrust.
Thrust. Yeah, you gotta make it go somehow. So thrust is what makes it go. Show my little model here. What makes this little model go besides my hand? Use your imagination. What would make this model go? The propeller, right up here at the front. Right up here at the front. So, how does that propeller make it go? Just simple. Just simple. The propeller does what? Spins around, creates thrust, and it pulls the plane. So, of course, behind the propeller is an engine or a motor. And what makes that motor go? Fuel? Yeah, it's not hard, see? Fuel makes the motor go, motor makes the propeller go round and round. You ever looked at a propeller, the shape of it? You know, a while ago I talked about the lift and having an airfoil on the lift. You create lift on the wing. You looked at a propeller to look at its shape. We'll get to propellers later on in another lesson, but when you notice the propeller is shaped also like an air, if you look at it sideways, that propeller sticking straight out, if you look at it sideways, it's gonna look like a little airfoil. What does that airfoil do? It creates lift. So we have a propeller that creates lift, except when it's instead of being flat like this, it's on a vertical frame. So the propeller, as it spins, creates lift. And so we have the same function. We have relative wind, and this is a propeller, side view. This is the nose of the cone. This is the airplane over here. This is propeller. This is right here. That's my little propeller right there. It's another propeller. So it creates thrust. Forward motion. So we also have our, what's this dotted line in the middle called? What's this up here? Main chord. So we have our main chord, and we have our winds. Except our winds are coming from a different direction. But we have our main chord and we have our pitch. Call that pitch. So if that's the main chord, I need to know where the, remember the LP and HP? LP is low pressure, HP is high pressure. So, which one is which? I'm gonna put pressure up here. This is our propeller. So which one's a low pressure, which one's a high pressure? Which one is this? Low pressure. Makes that high pressure. So we have a low pressure and high pressure on that propeller, because it's still a airfoil, which is Bernoulli's principle. And as that propeller spins, it creates the thrust. So now we've covered lift, drag, weight, and now thrust. How am I doing on time?
About 20 minutes.
For them and for high school, you have about 5.
Okay. Now to put all this together, we have these 4, that is a sloppy board.
Sorry.
I'll do better next time. These 4 elements, which 2 offset each other or opposites of each other? So if I have lift, what's opposite of lift? Weight. If I have thrust, what's opposite of thrust? Exactly. So if I have thrust, at some point in time, if I keep adding thrust and thrust and thrust, does this plane just keep going forever, getting faster and faster? Yeah, you meet your maximum thrust because of drag. The drag is going to get over here so great that the drag is going to slow it down. And at some point, we have lift, and we just keep climbing and climbing and climbing. What stops it? The weight. So at some point, the thrust and drag are going to be equal. They're going to be equal. In other words, I keep going faster and faster, and I finally find a stable speed. My speed, thrust, and drag are equal. I can't go any faster. I'm not going any slower. They're equal. And at some point, as I'm climbing, my weight and my lift, as I'm climbing, it won't climb anymore, so my lift and my weight are equal. This is some heavy thinking here. I mean, you got to think about it. So if I say, is weight and lift equal if I'm flying along? Yeah. What if I'm climbing? Is weight and lift equal? No, because my lift is increasing. If I'm flying along at a steady speed, is my thrust and drag equal? Steady speed. Absolutely, yes. If I'm flying along and I'm I'm getting slower and slower. I'm going faster, now I'm getting slower and slower. Thrust and drag equal, which is greater? Drag. If I'm accelerating, which is greater? Thrust. That's a hard concept to understand, because people say, hey, your weight and your lift are equal. Well, how can that be? If I'm flying along, how's weight and lift equal? Well, there's two times. You're sitting on the ground, sitting still, weight and lift are equal. And you're flying at a constant altitude. So that's the four forces of aerodynamics.
All right, y'all need to go.